Good afternoon, everyone. On behalf of Iritem Lucknow, I would like this opportunity to welcome all our audience, which are mostly domestic electrical users associated with railways and other ministries also, and spread over the whole country. These audience includes senior officials, middle officials, and field level officials and their family members also. On this occasion, I'd like to welcome our keynote speaker, Ms. P. Samal, who is Director, Bureau of Energy Efficiency and also a B certified energy auditor. She has been keenly associated with a number of projects associated with energy efficiency as well as energy conservation over the whole country. So I'd like to welcome Ms. P. Samal first. I would also like to welcome Mr. Sandeep Verma is well-known identity in the field of energy efficiency and who is presently working as a senior manager operations in BPCL Lucknow. Shri Verma is also a certified energy auditor and has been actively associated with a number of projects and training courses designed for achieving energy efficiency. As all of you know, every unit saved counts to mankind. I'd like to invite Ms. P. Samuel to kindly deliver her keynote address. Ms. P. Samuel.
Thank you so much, sir. And first of all, I would like to thank IRITM Lucknow for organizing this webinar on energy efficiency measures in residential and also service buildings. For service buildings, for us is the official buildings, right? So I will cover both commercial and residential buildings. So if I want to start from the need of energy efficiency in the building sector. Why energy efficiency is now a talk of the town in the building sector. So why all of a sudden we are talking about the energy efficiency measures in the building sector? Earlier, if you see, the importance was the industrial sector. And if we talk about energy efficiency measures, we generally talk about the industries because we feel that industries are the major guzzlers of energy consumption and the energy guzzlers. But slowly, if we see the shares of building energy consumption is now about 30% of the country's total energy consumption. So whatever country's energy consumption may be 1700 to 1800 billion unit. So out of that, 30% of that energy consumption is being actually consumed by the building sector. So that's why building becomes a major, the major focus for the government to implement energy efficiency measures. So that is the reason why Bureau of Energy Efficiency came into picture during 2002 under the Energy Conservation Act 2001. So Bureau has initiated many programs in various sectors like building sector, industry sector, demand side management, then the appliance sector. We have the standards and labeling for the appliance sector as well. You see the star labeling program 1 to 5 star. If you see your air conditioner, your refrigerator, your fans, now fans are the mandatory appliances now, and you cannot find fans without star labeling. So all these appliances are also being covered under the standards and labeling programs of Bureau of Energy Efficiency. So if you talk about the building sector, what are the activities Bureau has initiated in the building sector? So we have initiated the building sector activities during 2007. The first major initiative was the Energy Conservation Building Code. So Energy Conservation Building Code was introduced during 2007, which was primarily consisting the building envelope, majorly the building envelope and the electromechanical system. So, but slowly we realized that only energy efficiency is not everything. So sustainability aspects should be there. So now in 2024, with the amendment of Energy Conservation Act and the addition of sustainability factors in the Energy Conservation Act, we now introduce the Energy Conservation Sustainable Building Code. So I know that your focus is basically in the retrofitting of your buildings, and you are interested to know about the retrofitting option in your existing building. But you should also know about the existing facilities for the new buildings. And whenever the railway wants to build a new building, that it should know that if it is 100 kilowatt and above, I mean the threshold of the building, the connected load of the building is 100 kilowatt and above, then it is coming mandatorily under the Energy Conservation Sustainable Building. So the threshold of the implementation of this code is 100 kilowatt or contract demand of 120 kVA. So whatever new buildings in our country will be coming up over 100 kilowatt or 120 kVA, they will be coming under this code, Energy Conservation Sustainable Building Code. So these codes are available in our website and you can download this code. So this is nothing like only the 100 kilowatt buildings can apply. Any building can apply, but it is mandatory for the 100 kilowatt buildings. Even the small buildings also can apply. If I'm going to construct a building in my house and this is a 10 kilowatt building, I can also apply major segment of the Energy Conservation Building Code residential. Because we have two codes, one is commercial, second one is residential. So for residential, we call it as Eco Nivas Sanhita. So for commercial, we call it as Energy Conservation Sustainable Building Code, and for residential, we call it as Eco Nivas Sanhita. So in this code, there are three tiers. One is the basic, the compliance level. The Energy Conservation Building Code is the compliance level. Then the Energy Conservation Sustainable Building Code Plus, and now last May Energy Conservation Building Super Energy Conservation Sustainable Building Code. So ECSBC, ECSBC Plus, and Super ECSBC. So what is the percentage of savings? So we generally assume that if you implement ECSBC only, you can achieve 25% of the energy savings from a conventional building. And if you implement ECSBC Plus, then you can achieve 35%. If you implement Super ECSBC, then you can achieve 50% even of the energy saving of the conventional building. So basically, this is all about the new buildings provision that Bureau has prescribed. And this building code, earlier building code was Energy Conservation Building Code. This was the sustainability aspect was not included, but in this code, the sustainability aspect have been included. So there are majorly four aspects have been included. One is sustainable site and planning, water management and controls, waste management, indoor environmental quality. So earlier the earlier code was these parameters were not involved in the earlier code. So now the code, the ECSBC code is holistic in nature, and it also includes the sustainability aspect, which is at par with other green rating system like Griha, IGBC, LEED, and etc. And this the building typologies included in this code are hospitality, educational, healthcare, shopping complex, business, and assembly. So basically, the idea of this code, the mandatory code, is to make the new upcoming buildings of our country energy efficient. So at least the baseline 25% savings will be there if the baseline compliance would be there for the new buildings. And if we assume, it is not an assumption. Actually, as per the Niti Aayog report, 70% of our country's building are yet to come up. So whatever buildings we are actually witnessing today, 70% of those buildings are yet to come. I mean, in the next 20 years, 70% of this building will be built. So you can imagine that what is the amount of energy consumption going to be added in the building sector in the next 20 years. So if we if we see the broad perspective that within 20 years the building sector will consume about 850 billion units, and if we see what is the daily addition of the building, either for the commercial sector, about 3 lakh square feet is being added in the commercial sector daily basis. So every day 3,000 square feet commercial space is being added. So by 2030 it is estimated that 1 billion square meter in the commercial sector and 5 billion square meter in the residential sector will be added. So we can imagine the number of buildings, new buildings coming up in the next, 6 to 7 years, because we are already in 2026. So 2030 means within 4 to 5 years. So this is the need of the hour, why we are actually working very hard on the implementation of this code. The second thing that you are interested now today is the retrofitting option for commercial and residential building. So Bureau of Energy Efficiency also has developed the retrofitting manuals for the residential and commercial buildings with the help of Terry. So these manuals are available also in our website. You can download from our website. So these manuals, if you want to retrofit in your existing buildings, you can use these retrofit manuals. And there are 4 types of manuals. One is for the cold climatic zone, another is for the hot and dry other climatic zone. So for both residential and commercial buildings, there are 4 manuals are available on our website. You can download those manuals and you can go through these manuals, and wherever applicable, you can retrofit in your existing buildings. We have also we were implementing the star rating of the buildings, and you must be aware about the star rating of the commercial buildings and the star rating of residential buildings and the Shunya labeling. You must have heard about that, but for the time being, we have just hold the programs. Put on hold, and now we are going to come up with a mandatory notification for the large buildings which are 20,000 meters square and above. So wherever the buildings coming up, new buildings which are 20,000 meters square and above, they will be coming under this notification for taking 3-star at least. So if the building, you suppose the railway is planning to build a building which is the built up area is 20,000 meters square and above. So first they have to take 3-star star rating, then only they can get the approval from the authority to start the building construction. So these are all about the building program. We are also providing the financial support to the SDAs, the state designated agency. For you, PNEDA is your state designated agency. So we are also providing financial support to the SDAs to construct the super ECBC building. And till now we have provided support for 13 states for construction of super ECBC building, and out of 13, 6 buildings have been completed. So once these buildings are completed, these buildings will showcase that this is the energy savings achieved in comparison to the conventional building. So there is not much difference between the code and the retrofitting, because please don't be scared about this name code, because this actually includes your building envelope, which you cannot change in the existing building. So that is the difference between this code and your retrofitting option in the existing building. So But apart from the building envelope, you can apply other factors of this code like chemical waste and the sustainability aspect where then you can achieve at least 25% of the savings of whatever earlier the building was. So this is all about the initiatives we are working upon in Bureau of Energy Efficiency. We are very soon, we are also coming up with the cadre of energy auditors for the compliance of these buildings. These auditors will also help you in auditing your buildings, existing buildings, to know the energy saving potential. These auditors will also help you in designing your buildings. We are also working on the master trainer, creation of master trainers who will help you. Like today in the webinar, you are actually struggling. Who will be the master trainer here? So that he or she will help you in imparting the training to the officers. So once the cadre of master trainers will be there, you can just go through our website and you can contact the master trainer to impart the training. I think this is all about from my side, the activities and the programs we are implementing at Bureau. So
I would like to thank Mrs. P. Samuel for their enlightened knowledge about the building codes and all, etc. in energy conservation. So thanks a lot. You have spared your valuable time for enlighten us. Further, as a next step, we would like to invite Mr. Sandeep Verma. He's a subject specialist. So, Mr. Verma, please take your turn.
Thank you, Dr. Agrawal, for inviting me. And so first, we'll start with the energy conservation measures for residential and service building. And here we'll be talking about existing building. And in the later period of this program, we may briefly touch upon the ECSBC code, which was being referred by Samal ma'am. So I'll share my presentation. So in the context of Indian Railway, it is very obvious you have very large housing stocks for residential building. At the same time, you are largest public building owners, which you call it as service building. That will anyway lead to higher electricity consumption and at the same time present with a lot of opportunities for optimizing your energy consumption and reducing cost, and in turn contributing to your rather I would say nation's sustainability and carbon footprint reduction goals. All these measures have been developed considering different climatic conditions prevailing in various parts of this country. We normally consider five kind of climate zones. So one is hot and dry, another one is warm and humid. Third one is a temperate climate zone. Fourth one is cold, and last one is if you do not have any definitive kind of climate zone, we call it as a composite climate zone. So we have four types of prominent climate zone, and another last one is your mix of everything, which is prevalent to mostly northern part of country and rather north central part of this country. Hot and dry is desert areas. Warm and humid is coastal belt. Temperate, there are very few locations. Cold is obviously Jammu, Kashmir, and some part of northeast and all. So when we go for energy conservation measures, we have two types of approaches. First one is your passive retrofits. Another one is active retrofits. Basically, passive retrofits focus on improving building envelopes or building components so that we can improve indoor occupant comforts and at the same time reduce solar heating and cooling impacts on the building. So it basically look into consider your roof, your different walls, your fenestration means windows and glazed doors. So these are basically, though we have a five components, but primarily we are focusing on three critical components, that is roof, wall, and fenestration. This all we know, it is nothing but a normal physics. We there are three types of heat transfer mode, that is conduction, convection, and radiation. I need not elaborate on that. So first we'll talk about each and every component. So when we talk about, let's say, external wall, we focus on apart from once you have constructed the building, not much can be done about it. But obviously, you have to ensure that your building is airtight. There should not be undesired or unwanted infiltration taking place in that particular buildings. So that can be done in through various methods, like you can use POP, you can use some other sealing materials like silicon and all, depending upon the type of sealing you require. If it is, let's say, concrete structures, or then probably you can go for a POPs kind of thing, or white cements and all. And if it is maybe fenestration or glass and all, then probably you can go for gaskets, or you can go for silicon and all. Uh, then what we suggest that whatever glazing you have put on any particular face, if it is on west side, so we suggest if there is not, it is already, we should be having uh, shading devices available on the windows facing on the south side. Otherwise, we need to arrange for retrofitting shading arrangement further on the south side wall. We can also look into using wall insulation materials for external walls. That will help in reducing your heating or cooling load depending upon the climatic zone. Internal walls, we say that it should be preferably on light colors. It helps in light distribution, and in turns, it basically reduces your lighting load. This is one very important thing. This concept of cool roof. We There are various methods through which you can develop a cool roof, but I would say the easiest one, if you are using a cool roof paint, commercially it is available in the name of damp proof paints. So be it Asian, Berger, Birla, Opus, whatever, everybody is supplying these paints. They come with a warranty guarantee of 10 to 15 years. And these are basically light color paint uh, uh, with the high solar reflective index, and they help in cooling your roof by reflecting more and more sunlight. And this when it is used in conjunction with your renewable energy system, that gives you a pretty good payback, because now right now what renewable system we are using, or I would say renewable solar PV system we are using, they are bifacial panels, so they can generate electricity from the both side of panel. And if you are putting a coat of these cool roof paints, then it increases the your solar system generation also. At the same time, it cools down your building interior spaces as well. Alternatively, if you are not going for renewable energy systems like solar PV system and all, you can opt for vegetated roof. There are various ways you can develop your roof as a vegetated roof. You can put up like gamlas and all, and you can directly grow grass and other trees and greeneries and all. So if you directly want to use that roof as a garden place, so there are methods available. There are guidelines available in the manuals provided by Bureau of Energy Efficiency, which helps you in developing garden on the roof without compromising the your water seepages and all. So that complete uses of various layers has been detailed in the manual of Bureau of Energy Efficiency. You can also go for a roof deck shading. Matlab, you can put up not a structure on the roof so that it reduces your heat gain and in turn reduces your cooling requirement or heating requirement. Rather, I should say a cooling requirement in composite climate zone, or the climatic zone requires a more cooling. Insulation we have talked about for in case of wall also, and similarly you can go for roof as well. You can go for underdeck insulation. For fenestration, or we you can simply say that windows and skylights, or maybe glazed door like glass door and all. There are different types of glazing. Here, what we are referring primarily talking about the windows. So we have different types of glazing available. We can have a one layer of glass. We can have the two layers of glass, or we can have a three layers of glass. And normally these kind of fenestrations are available, or these kind of windows are available ready-made in the market. You have, based on the size of your window, you have to order and get it. You get it ready-made, and then you install at the particular location. And air tightness, I've already talked about in the beginning itself. When you are installing, you have to ensure that there is no unwanted heat gain. Unwanted air infiltration or exfiltration taking place through that fenestration. You don't want to, the window is already installed and you can't change it. Setting was one option I talked about for south face. This you can put up solar films or tinted films, which basically helps in minimizing solar heat gain, and at the same time reduces your UV transmission to the interior spaces. We have some dedicated high performance glazing systems also. I'll not get into these. Are basically especially designed glazing systems or fenestration, which basically at the same time, one it maximizes your passage of solar radiation and during the winter season, and during summers it blocks it. So it is a basically combination of your shading devices as well as your double glazing or triple glazing windows. You can either go for, as far as shading devices are concerned, you can go for a fixed shading devices, or we also have automated shading devices we'll cover subsequently. This is one very important parameter. If you have a large room, normally what happens, the windows are can help you in getting sunlight to the extent of 1.5 times of height of your window. But if you are using these light shelf, you can see that we have horizontal glasses kept. It can be internal light shelf also. It can be external light, which is kept out towards external side of building. Then it is called external light shelf. If it is kept inside the building, then it is called internal light cells. You can have either one of them or you can have both of them. They helps in increasing penetration of sunlight. So they normally installed at a lower level, slightly lower level of your window, and this basically helps in sunlight penetration. And then you can during daytimes you are basically you have two benefits. One benefit is that you are getting more and more daylight, and obviously when you are getting more and more daylight, and that too it is not coming directly to the interior spaces, so glare is less. You can usually you can properly utilize that sunlight, and it will reduce your artificial light consumption. We have other arrangements like light pipes also there. They are basically pipes which is normally installed at external surface, and then through pipe that normal natural sunlight comes inside the spaces. I know one example is there in your rail coach factory, Raebareli. We You have installed these light pipes, so this is a good way of doing. Normally, earlier we used to recommend that you should put up a transparent, transparent sheets on the roof of workshops. But what happens during summer time, we realize that it causes a lot of heat. With light pipes, since the light is coming inside through the pipe, due to lot of reflections, that infrared component which is causing heat gain gets absorbed in the process. So what you get a normal visible light at your workbench level, which is also important. Normally, if you are getting light at a higher level, you are not properly utilize that light. What is most important in usage of light is that you should get that light at a workbench level, that is roughly 0.8 meter height from the finished floor level, and that lux range should be between 100 to 2000 lux. Beyond these boundaries, because sunlight can go up to 10,000 lux also, and even higher. So such a higher level that you won't be able to see anything. If it goes beyond 2000 lux, you won't be able to see anything. It is only glare, nothing else. So these light pipes help in using sunlight directly. And you again, all these arrangements can be integrated with the help of sensors, be it your light cells or be it a light pipe. They can be integrated with sensors and artificial lighting. So to fully optimize your usage of artificial lighting, you can have light wells basically, but again it is a kind of thing which normally it subsequently after construction of building it is very difficult to incorporate. So it has to be planned in the beginning itself. It's like nothing else. It is like a simply having some kind of veranda or some which used to be there in the earlier buildings. आंगन जिसको हम कहते हैं आंगन kind of thing. And obviously, occupant behavior is very crucial. We are trying to replace occupant behavior with the sensor technology or BMS and all building management system. But obviously, unless the occupant is aware about it, you won't be able to fully optimize or fully optimize energy consumption in any kind of buildings. If you are in a, let's say you are sitting in a room or a residential building, if you should have a habit of switching off fans or light whenever you are coming out when there is no use. So similarly for office also, to some extent for certain application, for lighting application, you can go for sensor based technology, but again in residential setup it is not much of use. Commercial, yes, with carefully design and carefully placement, you can even if the occupants are not behaving in a manner they should, you can save energy, you can save power. Then operation and maintenance is crucial. Normally what we do in during Holi, Diwali and all, in residential, cleaning, periodic maintenance, lighting fixtures, your air conditioners, cleaning of filters. If it is a larger equipment, maintenance of motor or any other equipment, or maybe compressor and all, it is very critical. So periodic maintenance, both for residential setup as well as the commercial setup or service setup, it is crucial to maximize the efficiency of equipment which is being used. There are certain energy conservation measures which is specific to commercial building, like night ventilation. If suppose any building is operating during daytime, you can, and during night times the sky is cooler, the temperatures are lower. You can use nighttime air to ventilate your spaces, and again during morning you can switch back to HVAC system or a centralized air conditioning system. Uh, we already referred this. You can, instead of a normal setting devices, you can go for automated setting devices also. Uh, Obviously, effectivity you have to usage, you have to see whether it is justified in that particular scenario or not. There are some specific measures to residential building, like operable windows. You can have a sliding windows as well as you can have a double pane windows. The benefit of having a double pane windows that you can open up to 90% of window area. On the contrary, with sliding windows, a maximum you can go for a 50% opening. So, depending upon the space consideration, at times there could be places where you cannot go for a openable double pane window. So, you have to bargain for, you can be content with the sliding windows. So, like sliding doors at places, you have to necessarily put up sliding doors because you do not have space to open that door. So, depending upon the space available and the or the other consideration, you can select these kind of windows or doors. Then cross ventilations, it is very much required. Normally in residential building, we are using AC. Of late, we have been using a lot of air conditioning systems. But still, there is a lot of scope available for ventilation. So your building should be designed, or it can be retrofitted in such a manner that you have a proper cross ventilation. You can put up ventilator. Whenever you are doing these kind of cross ventilation observation, you should ensure that your air is movement is within the living zone. So we refer, when we say living zone, it is referred from again 2 meter height from the floor level. And if your ventilation is not happening through that zone, your that ventilation is not effective. You can go for openings, you can go for exhaust fans. You can use normal fans also, depending upon the spaces. But you have to ensure that your ventilation is taking place through living zone. This is one type of passive stack ventilation. It used to be there in the older buildings where stack effects is created, and from the top your hot air is coming out, because normally air movement is like that. If it is a cold air, it settles down, and if it is a hot air, it moves up because of being lighter in weight. So this is one way you can, if it is possible, you can go for passive stack ventilation system also. So this what we have been talking about, it is primarily, I would say, a bit taking, it's a more of a building design features. It is easier if you go in the beginning itself. It is possible, yes, it is possible, but it becomes a bit difficult when you go for it subsequently. Active retrofits, they are easier, but still at the same time, uh, once you have to change the equipment itself. So active retrofits can be installed in lightings for your air conditioning system, your water heating systems, your electrical systems. Uh, Behavior change we already talked about. Scheduling is required if you are going for a service building. Your lighting retrofit, it should be in such a manner that they consider the working hours or weekly usage pattern of that particular building, and then you can be further optimized with the help of sensors. Maintenance schedule, we already talked about it. This is one thing I was in the beginning. I was talking to Dr. Agrawal, and I was saying there's only very few measures where the technology has changed drastically. So one major change is there is that is LED lamps. They were there, LED lightings were already there, but because of certain reasons, they were not they were not very popular. We were not able to provide a white LED lighting system, which we are normally used to when we compare with in your CFL lamps or fluorescent lamps and all. So, and again, the cost has also gone down. The vis-a-vis your usage increase and the cost has gone down. So LED is one thing. Earlier we used to have a 100-watt bulb, and then we shifted to incandescent fluorescent lamps like your 40-watt tube light. And now with we can get the similar kind of lighting levels with the 15 to 20-watt LED systems. So there is a huge saving as far as when we move towards LED technology in lighting. And again, in LED, one thing I wanted to say, it is not that all LED lamps are same. You have to see the fine prints also. What is the luminous efficacy? How much lumen output is there for given wattage of that particular LED lamps? There is a wide variation available. You can have a lower efficiency LED lamps also. Just you may think that it is a cheaper, and actually it happens that it is also giving the lower output, lux output or lighting output. But at the same time, with a maybe marginal higher cost, you can go for a LED lamps, which is giving you much more light, and it is a value for money. There is one, I would say, a very highly ignored loads, which is plug loads. There is a lot of usage of your mobile phones or laptops and all of late. And what happens now? We are normally not using proper power usage mode with these electrical appliances. So if you are using laptop, you should have a proper power mode applied, which is either it could be balanced or it could be a high saving mode where, and you should ensure that if your laptop should be power setting should be configured in such a manner that if you're not using that laptop, your laptop should get into off mode, or your monitor should get into off mode, or it goes into a sleep mode. uh, this helps in the saving may not be very high, the but even the small saving with so many equipment, it becomes significant. This about it. Smart lighting measures are there, um, which is normally coming with a building management system. For a larger building, we normally recommend a building management system. These are the centralized systems, and they operate based on the data received from any particular section with the help of sensors, different kinds of sensors or monitoring consoles. and then we accordingly adjust the lighting level, the temperatures, and ventilation levels, all and all that, and accordingly we can optimize our power consumption. This is a task lighting. We normally recommend that you should focus on the task lighting instead of uniform lighting. More relevant in case of office spaces, but we have seen a very limited success to this because of maybe our mindset. We are not very inclined towards task lighting. This concept is very old, but our inclination towards task lighting is not much. We generally recommend that in case of office, your maximum lux level should be on the table instead of background lighting. So this is one thing which can be looked into. It can give you quite reasonable uh, saving in terms of power. Another thing is you can rearrange your fixtures, lighting fixtures, to have a proper light distribution that is required. So that wherever you require lighting, you should have a proper. It should not be at too high level. The lighting fixture should not be too high, or it should not be at the same time too low. Accordingly, you can adjust the height of your lighting fixture. You can adjust the location of the lighting fixtures so that you are with a lesser number of fixtures, you can get the desired result. This is basically adaptive lighting controls. This I've already referred earlier. Here, what you do, you use various kind of sensors in conjunction with day lighting, and whenever you see that your day lighting is more, you go for switching off your artificial lighting, and the gradually when your day lighting gets faded, uh, you increase the supply to your artificial lighting, and you keep a balance. So you keep a balance in such a manner that you get a desired uh, your lux level at the work plane. It is not only switching on, switching off with LED. It is becomes much easier. It is you can modulate the voltage supplies, and accordingly you can regulate the lighting output, which was which was not much possible as with earlier types of lighting systems. So this is one thing. Another thing which we are getting benefited because of LED lighting technologies. And now moving on to your HVAC system. HVAC system is nothing but the heating, ventilation, and air conditioning system. Uh, your The problem is with your air conditioning system. Our air conditioning system are still using compressor based cooling system, and compressor being inherently very low efficiency. We consume a lot of electricity. A lot of work has been done of late. Though the concept was there, but because of other considerations, we were not able to enhance the efficiency of our air conditioning systems. Now, with the advent of screw compressors, high efficiency screw compressors, and then we have variable frequency drives which can control the speed of your motor attached with your air compressors in a much more finer way. So you can optimize the consumption of your air conditioner. Like what you here is the inverter ACs. They are nothing but air conditioners fitted with the VFD system. So, and then for ventilation, there are various types of ventilation strategies which we'll talk about. Similarly for heating also. For different climatic zone, we recommend different types of your air conditioning system. So for like hot and dry climate zone, we can go for variable refrigerant flow system, um, along with the cool roof. For warm humid climate zone, you can go for a dedicated outdoor air supply system, DOAS, along with humidity control. And at the same time, you can go for thermal energy storage system also, uh, in order to utilize the variation in temperature during evening hours. So that can be done in the warm and humid climate zone. In warm and high humid climate zone, you need, since the evaporation is very limited in a humid climate zone, you need either you go have to go for a bigger cooling towers in order to achieve the desired evaporations to ensure proper cooling, or it is recommended that you should go for high efficiency cooling tower. There are high efficiency cooling towers are available with they have got multiple features like the kind of filling material it is there, the kind of nozzle it is there, all these the fan use of speed control technologies. So we have high efficiency cooling towers, and it is very much recommended in a warm and humid climate zone. In temperate climate zone, you can go for geothermal heat pumps, and you can also use a night flush ventilation. Night flush ventilation we have already talked about. For achieving heating effects, basically we lay down pipe in the basically earth, a lower level of earth, and we and through that we circulate waters, and that water is used for a heating purpose, and alternatively cooling purpose depending upon the climatic conditions. And it is to duct sealing. Obviously, if you are using a delivery mechanism, it should be properly sealed, especially when it is passing through unconditioned or outdoor spaces. We also need to have energy recovery ventilation system. There, what we are using. We normally need to take fresh air from on time to time basis, and at the same time, certain amount of stale air which is there in the indoor spaces, you need to exhaust. So they should not come into direct contact, but at the same time, the whatever which is getting exhausted, it is cooler in nature. If let's say we are going for air conditioning, it is cooler in temperatures, and the air fresh air which is coming from outside, it is hot, having a higher temperatures. So they can have a heat exchange, and the outdoor air can be cooled down with the help of a stale indoor air. So that will reduce load on time to time load on the your air conditioning systems. Similarly, for lighting, you can also go for sensors for your HVAC systems, or you can use a building management system as well. For ventilation, normally there is a one terminology called demand control ventilation. It is mostly it is recommended for basements where you have car parkings, where it is suspected that you can have a higher concentration level of carbon monoxide. So we install a CO sensors, and based on reading of CO sensors, we ventilate that basement parking. It is there in ECSBC also, and for a larger spaces, we go for CO2 based sensor, where based on the CO2 concentration, we ventilate any space. Otherwise, it is based on the some experience of fixed ventilation, that where there's some opening is there, and you are ventilating irrespective of occupancy, which is consuming more energy. Air filter maintenance, we have talked about it. It is also crucial for residential buildings. There's another system, that is variable air volumes system is there, which can be installed. It is normally installed on the air delivery systems, which is ventilating the indoor spaces. Then, as far as water heating and plumbing retrofits are concerned, you preferably you should use either solar energy, solar heating systems, or you should be using a waste heat water heating systems. In absence of that, you should go for a gas based system. And as a last resort, it is recommended that especially in service building, opting for electrical systems. A residential system, not much of the options are there, yes, but we have 5-star rated geysers are available. We can opt that in order to reduce your power consumption. For plumbing, we can go for sanitary fitting. We know that we have a half plus, full plus, a 2+ system that saves a lot of water. And similarly, and water is obviously you are getting through pumping systems. So if you save water, you save load on the pumping system, and it saves energy. We have different types of water efficient, I should say, sanitary fittings, or your faucets also, yeah, water fittings also, and they dispense lesser water per minute, and they also use air mixing in order to provide a desired effect. And in turn, obviously, it saves you power. Behavior change, it is everywhere, it is relevant. In hot water, you need to optimize the hot water temperature. To what extent you need to go for a hot water temperature. Accordingly, you need to adjust thermostat settings. Insulation of piping system, obviously relevant, because you are delivering, be it a cooling system or a hot system, proper insulation is required on the delivery mechanism, ducting as well as piping system. Low flow fixtures, we have already talked about for ensure water conservation. This is one thing. This is basically related with waste management. Normally, what happens, there is a lot of water which is coming out of our day-to-day usage, which is not biocontaminated. Let's say you are taking a bath, so that water, yes, the water which is getting used in urinals, or which is used in your toilet, they are biocontaminated, and they are called as the black water, and they should be treated separately. The strategies are there, but as far as gray water system, you can treat that gray water system and utilize it for your gardening, or maybe cleaning your common area cleaning, or maybe cleaning your vehicles and all. So these gray waters can be easily used for your non-critical, non-human applications. For as far as electrical systems and appliances are concerned, we recommend going for higher efficiency system. Let's say for power distribution, you should have a high efficiency transformers. Variable frequency drive, we have already talked about it. This is energy efficient transformer. This is one thing, though I'm sure a lot of people would be aware about it. power factor control systems. What happens for any electrical systems? You require two types of electrical power. One is called reactive power, and the one is called active power. Active power is that power which is in turn giving you a mechanical output, which is used, which varies with your quantum of mechanical output. Reactive power more or less remains constant throughout the operation of that particular equipment. They basically help in establishing your magnetic field in the motor. And what happens, you normally, you either you draw it from the grid, or alternatively you can generate at site without much of the investment with the help of a capture bank and providing proper controls. Whenever you require reactive power, that can be catered locally. So it helps in basically reducing your power which is being drawn from the grid, and at the same time it is if we get into a depth, we see that it also helps you in reducing the your resistance losses or power losses which takes place in the your distribution system. Energy star rated appliances, yes, for a residential setup, you should preferably go for higher star rated equipments. They in terms of life cycle cost, they are much more economical. They may have a slightly higher initial cost, but in the long run, over the life of that particular equipment, they give you very significant savings in terms of power usage. Then load management, it is relevant in case of, it is more relevant, I would say, in case of service building, where you have to schedule your loads. There could be certain application you need not, don't want to run in during normal hours or during peak hours, or rather because in service buildings, we have, depending on upon the time of day, your trials are different. But it is not there in the residential building. But using load management in residential building is also relevant. We'll talk about subsequently. During service buildings, you need to schedule your loads in such a manner so that your overload load is within the sanction limit, and you are not end up running a non-critical application during peak hours, and in turn increasing load on the grid. In case of residential setup also, let's say you are using washing machine. So washing machine you can use, you can run in such an hour where you are not using AC or you are not using geysers. Maybe just after people have gone to the offices and all, that could be an ideal time to for using washing machines. So that these kind of load management also can happens in your residential setup. But it is in case of service building or commercial setup, they are much more beneficial. Power factor improvement, we talked about it. Renewable systems, mostly we are focusing on solar energy, but yes, there are other systems are also available which can be used. Solar energies, normally we go for solar photovoltaic system, but we can also opt for solar water heating systems and light pipes. All these are basically based on the usage of solar energy directly or indirectly. Wind energy, there are normally earlier we used to have a horizontal axis windmills. They were relevant in case of high wind velocities, and more seen into coastal belts and all. But with vertical axis enhancement in the technology of vertical axis wind turbines, with a lower wind velocity also, and with the lesser space, we can generate electricity. So they are now being deployed alongside highways and all, where we can generate electricity and in turn use in nighttime applications. Biomass, I can say that if you have any canteen facility, centralized canteen facility, a lot of food waste are coming out of it, and that food can be used for generating energy as well as you can generate biogas, and in turn that biogas can be used for multiple applications, or you are also getting manure which can be used for plantation purpose. We have geothermal technology, but it is relevant at certain places only. These are some of the case studies, both for commercial and residential setup. This is New Maharashtra, Southern New Delhi. It is a composite climate zone with a built-up area of almost 16,000 square meter. This is a commercial building. What we did in this building, we have replaced old electrical equipment with star-rated equipment, and we have used LED lightings, and at the same time we have installed a renewable energy system, that is solar photovoltaic system, 150 kilowatt. And in HVAC system, we have installed a de-superheater. So basically, what are it basically reduces energy consumption of the condenser of HVAC system and improves its efficiency. The waste heat recovered from de-superheater is used to raise the temperature of hot plate heat exchanger, helping increasing temperature of water stored in domestic tanks. So यहाँ पे हमने waste heat recovery करी, जो आपका कंप्रेसर से एग्जॉस्ट आपको आउटपुट मिल रहा था, उसको हमने पहले कूल डाउन किया, और उसके बाद हमने फाइनल उसको फर्दर कूलिंग के लिए उसको हमने कंडेंसर में भेजा, एंड कंडेंसर इन टर्न इट इज गेटिंग कूल्ड थ्रू ऑब्वियसली either through fans or through if it is a water cooled system, you go for a cooling tower. So this is the one setup. De-superheater is basically a waste heat recovery system. Pardon?
कुछ ना कुछ हुआ होगा, रीजन नहीं।
प्रवीण जी, ओके, ठीक है। We also installed energy meters on utility grid as well as utility grid. It was anyway there. For at the same time, we have installed on the energy meter on the solar PV systems, your renewable energy systems. We have installed water meter also in order to ascertain what kind of water consumption is there. Similarly, for residential setup, we have done the retrofitting in a place in Indore. That is again a composite climate zone with a built-up area of 340 square meters. That is roughly, I would say, 3,500 square feet. Here we have installed insulation on the roof. We have gone for active low energy cooling systems. Using of all equipment which is 5-star labeled, and also installation of solar PV system of 7.5 kilowatt. So this is all as far as different types of energy conservation measures are concerned. Let me summarize once again. For roofs, basically you can go for cool roof paints, which reduces your temperature, and if you are installing your renewable energy system or solar PV system, it increases its output. So that is the one thing can be done about it. For windows, you can go for a shading arrangements. What I'm talking about is some mostly low cost, easy affairs which can be done without much of the efforts and investments. So you can go for a shading arrangements, and especially on the south side of your wall, south side of your building.
So I was summarizing basically. I was saying for roof you can go for a cool roof paint, which is a very easy application with not much of the cost, and savings can be tremendous, especially if you are using a solar PV system on the roof. Then again, you can go for shading arrangements, especially on the south side of your building, south facing walls. And then for electric, whenever you are going for appliances, you should go for preferably 5-star rated equipments, or energy efficient equipment. For fans, we have BLDC fans, or energy efficient when they consume very less energy as far as fan power is concerned. So for a larger setup, you can install sensors for multiple applications, or even you can go for a building management system, depending upon the financial viability. And again, bottom line remains the same. Whatever technology you are using, human awareness is very much required. If occupant is aware about it, then only you can fully reap the benefit of whatever measures you have taken towards energy conservation. So, Dr. Yeah, this was it was the first session, and if you want, I can take it forward and cover some elements of your energy conservation and sustainable building code, which is primarily aimed at new buildings. Samal ma'am was referring, that is ECSBC 2024 Energy Conservation and Sustainable Building Code. This code is aimed at commercial buildings and new construction, having a plot size of more than 1,000 square meter. Similar to this, we also have a building code for residential building, Econivas Sanhita. That is also that 2024 version also talks about the sustainable elements. There are only minor differences as far as both the codes are concerned. One is rating system or evaluation system is concerned. For residential setup, it has been more of a marking oriented or simple. Whatever you do one thing, you get certain marks. It is like that. And in case of ECSBC, it is either you have to follow the guideline, that is one way of doing it strictly, or if you are making your own design, then you have to demonstrate the building energy performance through software simulation. So, which is only feasible in case of commercial setup, not feasible in case of at this smaller residential setup. But yes, for a larger residential constructions, it can be done. So this energy conservation and sustainable building code was originated in 2007 with only 4 elements of energy, and then going forward in 2017 we came up with the refined version with higher level of compliances, and now in 2024 we added elements of sustainability so that we can have a comprehensive guidelines for constructing new building, and with all kind of elements incorporated in a one single document. In this, what ma'am was talking about, we have a one mandatory compliance level, that is ECSBC. Then we have a higher compliance level like ECSBC Plus and Super ECSBC. And when we say, so now even we are talking about net zero or near zero buildings also, which is a part of another study or another. Basically, government body is looking into that. So in this code, we have basically total 8 elements in this latest code or latest guideline or document. You can say that the code appears to be a bit more cryptic. In this basically section is sustainable sites and planning. So it basically emphasizes in soil preservation, topsoil preservation, which is roughly your 200 from the surface. That is used for your greenery purpose for developing greenery and all. So that should be preserved, and it should be reutilized preferably on site for developing green belt, or it can be shifted to any other off-site location also. Again, the same, it must be used for developing greenery only, developing a green belt only. So that topsoil has to be preserved. It should not happen that you are constructing a building on a large plot and then you end up wasting in the entire fertile soil which is present on that particular site. Then we also said that whenever you are developing a site, you should ensure a basic access to the amenities as well as transportation system, rather I should say public transportation system. Amenities like ATMs, grocery store, medical store, gym and all. So minimum, we say that minimum 4 amenities should be within 800 meter of distance. And similarly, for transportation system or public transportation system must be within 800 meter distance of that particular that building under consideration. If it is not that, most of the time you are not able to decide the location of your site. And unlike amenities which you can develop on site also in collaboration with some other vendors. For transportation, you need to provide a bus system so that bus can drop to the people at nearest public transportation system. So for 25% of occupants, you need to have your own fleet, a bus fleet available. Then for accessibility point of view, your building should be properly accessible with proper signages and toilets available for senior citizens, children's and differently abled users. So for that, you need to have a parking spaces available. You need to have a separate toilet available. You need to have a ramp. You need to have tactile flooring. So all these kind of arrangements are required once you are developing building which is under the scope of this code. Then as far as building envelope is concerned, we have certain standard which must be followed. There are some parameters which has to be followed, be it a opaque construction like wall or envelope sealing. We have already talked about it in the earlier section. The same way your envelope should be properly sealed. There should not be any kind of unwanted heat exchange between external and internal environment through air leakages. And we have also emphasized on the usage of daylighting. That parameter is being defined as UDI, useful daylight illuminance. So your 40% of your area which is receiving sunlight must meet that UDI requirements. Similarly, for fenestration, we have certain parameter that has to be followed. Either you can either go for a standard material which is being referred in the code, or you can make your own design and ensure that overall energy performance of that building is better than your standard building power consumption. For HVAC system, we talk about ventilation requirement. We talk about proper insulation. We talk about equipment placement. We talk about proper commissioning and balancing of the systems. So these are the things which we look into. We have to look into the air heating, ventilation, and air conditioning systems. For lightings, proper control has to be there. Your lighting must conform to certain standards in order to ensure proper quantity and quality of that light. You need to have proper emergency lighting. You need to have we have given a guidelines for you how much light you can use for exterior purpose and different spaces, and similarly for interior spaces and all that. For electrical and renewable energy, we talked about the loss levels for transformers. We have talked about UPS efficiency. We have talked about power distribution losses. We have talked about voltage regulation. We have also emphasized on earmarking spaces for renewable energy. For water management, we talk about proper sourcing of water, that and then use of efficient fixtures, which is meeting your flow and flush benchmarks, use of rainwater harvesting systems, and then water metering also. And whatever wastewater which is getting generated on site, if it is a black water, that must be treated to convert into a gray water and then disposed of. And if it is a gray water, then it has to be treated and converted into a for a non-potable application. Non-potable, it is it can. I've already explained earlier that for cleaning and non-human applications, it can be used. For waste management, there are two levels of waste management. One is a pre-construction and the another one is a post-construction. For pre-construction stage, you need to segregate your hazardous and non-hazardous waste, and it should be disposed of as per the guideline prevailing in that particular area by Nagar Nigam or any other designated agency. Post-construction, again, you need to segregate waste properly, dry waste, wet waste, and then again, it should be further segregated into hazardous and non-hazardous waste. And then while disposing that hazardous, especially hazardous waste and that to biohazardous waste, proper guideline has to be followed. You cannot dispose of biohazardous waste just like that. And that record has to be kept and maintained. But then for indoor environment, we talk about indoor air quality as far as PM 2.5 and PM 10 is concerned, maintaining your CO2 concentration level, proper ventilation has to be ensured. Then acoustic guidelines like you have to provide sound insulation so that the noises which is there on the outside should not disturb the occupants. Then we also talk about your visual comforts. Visual comforts, we talk about glare control and color rendering index as well as the lighting lux level or scale of following up a scale of illuminance. And then for thermal comfort, we say that not only temperature level, as well as the air velocity and the humidity level must be maintained to ensure proper thermal comfort for the occupants. This is a typical comparison between normal threshold mandatory compliant building and the higher compliance level. Let's say for it is a normal office, so which is anyway 25% more efficient than a conventional office. If you are having a ECSBC office with the performance level of let's say 1, then in comparison to that ECSBC plus building will have another roughly 14 to 50% for 15% further saving. And if you talk about super ECSBC, it provides you from mandatory level to roughly 22% kind of energy saving for a normal office which is operating on the daytime. There could be places like school and university, you can achieve up to 34-35% saving also if you go for super ECSBC buildings. As far as initial cost is concerned, we have initial our capex goes up by 2 to 3%, but at the same time our water consumption goes down by 30 to 40%. Our emission goes down by another 30 to 40%. Your waste operational based waste generation goes down by 30 to 50%. Your cooling system will be much lower because you have made your building envelope more resilient to the external environment by using a proper material. And reduction in operating cost by 8 to 9%. Reduction in energy consumption could be somewhere between 25 to 50%. And the payback period is 2 to 3 years. So this was ECSBC on basically designing a building. There are some elements which we are not normally suggesting, like kind of bricks, what kind of bricks you should be using, like aerated autoclave bricks are AAC blocks are there. You should be using that AAC block in order to have a better building envelope which is immune to external environment conditions. With lesser heat gains, you should go for a double glazed or triple glazed fenestration system. You should optimize the usage of glass or glazing, and because normally glass designs, which is very prevalent, you see that in Gurgaon and all, DLF especially, they are inspired by Western countries. If it is a cold climate, which is not much in there in our country, barring cold climate area, in remaining places, higher usage of glass is not recommended. It puts a lot of load on your air conditioning system, which is the biggest energy guzzler of all the appliances which is there in the building. Lighting, it is very simple. You have to go for energy efficient LED lightings, and all these things must be controlled. With the help of IoT devices, now we have a further advent in sensor technology. We are talking about Internet of Things, IoT sensors, which is directly interact with your server and pass on that data. And based on that data, you can make decisions. And if you can integrate machine learning and artificial intelligence, you can have a continuous improvement optimization for a particular building. Instead of a manual intervention. For a normal system, if you don't want to go for that kind of higher investment, even then you have to look into the manual controls. Then with a normal sensor, it can work. So this is all as far as my side is concerned.
Thanks a lot, Mr. Sandeep Verma. You have given a very comprehensive material on the energy conservation. Definitely we will try to imbibe that material and try to implement all those aspects. I'd also like to thank all the audience who have spared their precious time for connecting to us and participating in this webinar. Thanks a lot for everyone. Thank you. Let's conclude.